Hello students, today we are going to discuss how to connect the resistors in an electric circuit. Here we have two ways. Let us see what are they. If we have more than one resistor, how to connect them in an electric circuit? Here you can see two ways are there. First one series combination, second one parallel combination. Here you can see two resistors. These two resistors are connected in series. Series means N to N connection. Here you can see three resistors. These three resistors are connected in parallel. Parallel combination means you can see these three resistors are connected together between 2 points A and B. You can see first terminal of the first one, second one and the third one are connected to the point A, and here the second terminals are connected to the point B. This combination is known as parallel combination. Today we are going to discuss the resistors connected in series. Here you can see three resistors are connected in series. R1 is the resistance of this resistor, R2 the resistance of second resistor, R3 is the resistance of third resistor. Here you can see these three resistors are connected between X and Y. Here these resistors are connected in series, N to N connection here. Now we have to discuss about the current and voltage in this circuit. So here what about the current? This is series circuit. You know children, ammeter is always connected in series. In an electric circuit, keep that point in your mind. By that we can say here the current passing through each resistors is same. We can consider I is the current passing through the circuit. Here you can see through R1 I is the current, then the same current is passing through R2 and the same current is passing through R3. So this is very important. Current through all the resistors same here if these resistors are connected in series. Then in the circuit you can see battery here, ammeter for measuring the current, then resistors, then across X and Y you can see voltmeter is here, then key here. Why this voltmeter connected across this X and Y? If this is connected between X and Y, from that we can say we are getting the potential difference between X and Y. That we can take as V. Okay children, so here in series circuit current through each resistor is same, but what about the potential difference? Here the potential difference is different. You can see this voltmeter is connected between X and Y. If you have three other voltmeters, if you are connecting one voltmeter V1 across this resistance R1, this voltmeter gives you the potential difference across R1. Here I is the current passing through R1. We can take V1 is the potential difference. I told you in series circuit potential difference across each resistor is different. Then another one voltmeter we can take that as V2 and connected across this R2 means you will get the potential difference across the resistance R2. Like that one more voltmeter there, V3, that gives you the potential difference across this R3. Children, here you can see 3 voltmeters. Okay, V1 gives the potential difference across R1, V2 gives the potential difference across R2, V3 gives the potential difference across R3. Here you can see V is the potential difference across these 2 points X and Y. That means V is the potential difference across these three resistors R1, R2 and R3. From this we can write V is equal to V1 plus V2 plus V3. Once more children, here these three resistors are connected in series. We have to consider current and potential difference. I is the current passing through this electric circuit. That is the total amount of current in this circuit. The same amount of current is passing through R1, same is passing through R2, same amount is passing through R3. But here the potential difference across each resistor is different. If you are connecting on voltmeter here, V1 gives you potential difference across R1, V2 gives you that across R2, V3 is the potential difference across R3. So from this we can write the total potential difference across these three resistors as V is equal to V1 plus V2 plus V3. Okay children, now we are going to replace these three resistors by a single resistance. We can call that resistance as effective resistance or equivalent resistance. Okay, how to remove these three resistors by a single resistance? Here we have to use Ohm's law. So by applying Ohm's law, here you can see V1 potential difference across R1. By applying Ohm's law, you can write V1 is equal to IR1. V2 is equal to IR2. V3 is equal to IR3. Clear children? Now I told you we have to remove these three resistors by a single resistor. The resistance of that resistor is effective resistance. Now we are going to derive one equation for this effective resistance. So for that we have to consider these three resistors should be replaced by a resistance R. We can take that as R here. Then here you can see V is the potential difference, I is the current passing through that. From that we can write V is equal to I into R. Now we have equation 1, 2, 3, 4 and 5. Now we have to substitute that equations in our first equation. Then you will get IR is equal to IR1 plus IR2 plus IR3. I is common now. So here we can take I outside, R1 plus R2 plus R3. Here you can cancel this I, then you will get R is equal to R1 plus R2 plus R3. This resistance we can write as R effective or R equivalent. That is the sum of resistance of these three resistors. R effective is equal to R1 plus R2 plus R3. Then how can we draw this circuit again? Like this way. Here you can see V is the potential difference. Here X and Y. Here you can see ammeter, cell, key. Then here positive, negative. So here you can see now, can you compare these two circuits? Here you can see three resistors between X and Y. Here I replaced that three resistors by a single resistance. We can call that as R effective. Effective resistance of these three resistors connected in series. Or we can say this as equivalent resistance of three resistors connected in series. That means children, if you are connecting resistors in series combination, effective resistance will be the sum of resistances of each resistors. All these resistors are connected in series now, so you can write effective resistance like this way also, RS, that is equal to R1 plus R2 plus R3. If 5 resistors are connected there, what will be the effective resistance? R1 plus R2 plus R3 plus R4 plus R5. If 10 resistors are there, you have to take the sum of all that 10 resistances. Here you can see we are taking the sum now. So here the effective resistance will be greater than any individual resistance in the circuit. For example, here we can take 1 ohm, 2 ohm and 3 ohm connected in series. So what will be the effective resistance? 1 plus 2 plus 3. 5 plus 6 ohm, that is the effective resistance. If you are comparing, you can say no, that is greater than 6, here it is that is greater than 1, here it is greater than 2, here it is greater than 3. If you are comparing these three values, which is the greatest value? 3 ohm. So if you are connecting resistors in series, the effective resistance will be greater than the greatest value of resistance in that circuit. In case of the series combination, no need to say about the advantages, but here these disadvantages are very important. You have to know electrical appliances are not connected in series in our home. What is the reason for that? You know, each electrical appliance need different amounts of current. Here you can see they need currents of different values. You know, if these are connected in series, the current passing through all the appliances will be same. That is not practicable. So next one, if one component fails, other components cannot work. Here you can see all these are connected in series. Here what will happen if this is not working? What will happen? The circuit will be a broken circuit. Current cannot pass through that and other components cannot work. Then you know, children, here the effective resistance will be the sum of all the resistances. So here what will happen? The total resistance in the circuit will be increased and the current passing through that will be decreased. Next class we will do some numericals based on this concept.